m by 2. Remember this point, all the nodes except the root will have at least means 0 to that extent, right? This extent to more. So m by 2 minus 1 keys and maximum m minus 1 keys will be there in each node, right? And non-leaf nodes, that means the internal nodes or intermediate nodes must have at least m by 2 children. If the root node is a non-leaf node, it must contain at least 2 children. That means it should follow the property of binary tree. The non-leaf node with n minus keys must have n children. That means n leaf nodes. All the keys in the root must be in the ascending order. That means it should follow this property of binary search tree. Suppose if you want to add some elements into the binary tree, we should follow the thing like left less than root less than right. In the same scenario, if you want to insert a node into the binary tree, we should concentrate upon the order of the tree, followed with the condition of binary search tree, and all the leaf nodes should be in the same level. That means the splitting will be done from the bottom to top, not from the top to bottom. That means it should have at least m by 2 minus 1 keys and m minus 1 keys maximum. Right? Are you clear with this property? Yes. Here we go with the B plus trees. B plus tree means it is basically for indexing the multiple levels. The comparison between the B tree and B plus tree is data pointers in the leaf node must have more process accurate and faster in the B plus tree. That means it will be little bit faster. How it will be little bit faster means it leaves some extra space to store the internal nodes. How that internal nodes will be stored and all we'll see with this property. Here are the rules for the B plus trees. Leaves are used to store the data records. It's stored in the internal node of the tree. If the target key value is less than the internal node, then the point is just to the left side of it. That means whatever the thing you want to insert into the tree, into the internal node, if the internal node is, if the key which you want to insert is less, means you should shift it to the left side. If the targeted value, that means which you want to insert into the tree, is greater than the internal node, means please point it as the right shade. Then the root will be having minimum at least 2 children. Why to use this B plus trees? And the operations performed on B tree and B plus tree are one at the same. But B plus tree will have some more features which I'll be discussing in the coming up few more minutes. But meanwhile, please look into the reason why do we use B plus trees. Okay. B plus tree will manage the increasing or decreasing of the trees very perfect when compared with the B tree. That means it uniformly divides equally all the internal nodes. All the internal nodes and all the leaf nodes will be placed at the same level. Right? These are the some of the properties of your B plus trees and B trees. Here are the differences between the B tree and the B plus tree. B plus tree, search keys can be repeated. That means the since here is, suppose you are having a root node 10 and the left child 5, right child 12. Here the internal node will be replaced with 5, 10 in order to replace the null value of the order M. So here it replaces 12, 10. So redundancy is more. That means repetition of the value. Duplication is not there. Repetition of the value is there. Whereas redundant cannot be applied. Whereas in the B trees, we don't follow such kind of thing. Data is only saved on the leaf nodes. That means every time the insertion will be done on the leaf node. Suppose if there is a possibility in the internal node, if there is a space, then also it will add up to the internal. That is the case of your B tree, whereas in the B plus tree, it can't be possible. Data stored on the leaf nodes make the search more accurate and faster. Searching is slow, whereas insertion is fast. Deletion is not difficult because repetition of the things are there. Deletion of the elements is complicated because time-consuming process. I need to search the tree, half part of it, depending on the M array. Right? Linked leaf node make the search efficient and quick. That means here repetition of the values were there, no? So it makes my searching easy. So such kind of repetition was not there, no? So it can't be that much easy. Remember these points. Try to learn as early as possible. Okay. Right. So coming to the next point that we need to perform set operations. Set here in the sense we need to perform the hashing. Hashing means what? It is also a data structure used to store the data in terms of a table. And in each row, it follows a pair of values. What is that pair? Key value and value type. Key value and value type. That means the value it takes and what is the key you want to give it to it. So ID followed with the value. Right? So here are some keynotes related to your Splatrix, but that is not the coding part. We'll discuss this in detail. Meanwhile, let me give you the properties related to the here. Okay? Am I clear? B trees and B plus trees. These are the codings for the B tree and Splatrix. This is what a set which will be mapping with the values. Hashing means storing the data in the hash table. This table will contain the rows. In each row, we'll be having some index to it. Based upon that index, we'll be inserting the value that is pair key and value, right? So here, hash table has a limit. Dynamically, if I want to increase, no, it takes some huge that huge amount of memory. So before going to the implementation of this hashing, let me give you some basic definitions. That is hash function. Hash function is a function which is used to store a value into the table. Based upon the return type of this function, the appropriate value will be placed into the table. That value which is returned by the hash function is called your hash key, right? And by using this hash functions, I may get collision. What is meant by collision? Same value, same key is generated by more than one value. In that situation, we will be getting collision. In order to resolve this collision, we need to follow collision resolution techniques. Okay? Those are linear probing and all. First, let me give one example related to the hashing. Suppose, I'll just share the whiteboard. Suppose, here is your hash table. I'll just draw it. Here is your hash table. I'm sorry. Wait a second, ma'am. Here is one hash table. Or else I'll take the text. Think its size is of 5. Two, 3, 4, 5. Think The hash table size is 1, 2, 3, 4, 5. I have taken like this. And now I want to insert 45 value with the method like division method. In order to implement the values into the hash table, we are having different hash functions. 5 different hash functions were there, ma. First one is the division method. The formula is key modulus the size of the hash table. Suppose here I want to insert the value 45. So 45 modulus size of the hash table is 5. 45 modulus 5. What is the remainder? What is the remainder? Remainder is 9. Is it in the range of your hash table? No. Please change the size of your hash table to the size of 10. Think you have taken 1 to 9 values or 0 to 9 values. Now you achieved the key for 45 is 9. What is the key value of your 45? 9. Under 9, the location in your hash table, you are going to place the value 45. Suppose if you have taken the value 55, modulus 10, not 5, ma. Here we have taken the size of your hash table as 10. So the remainder will be 5. Even here also, the remainder is 5. In this scenario, please look at here. 45 is retrieving the same key. 55 is also retrieving the same key. So in this situation, both the keys 45 and 55 are locating to the same location. This situation is called collision. In order to remove this collision, we are having collision resolution technique. That is linear probing, quadratic probing, double hashing and all. Under linear probing, what is the thing we will be following means, once you fill the 45 value under the location of 5, if the next empty bucket, you need to place the 55. In the next empty bucket, we need to place the 55. This is what the scenario we usually bring into your, bring into your notice. So linear probing means once the key is filled in that particular key, then start moving to the next empty bucket and insert it into the particular location, right? This is what the linear probing technique, which is used to handle the collision. And by this linear probing, we had one problem. That is, we are not locating all the values by using its key. We are just changing the position. Suppose some other value which is having the accurate key, which has to be placed in that appropriate key, is not having a bucket free over there to fill into it. So to overcome this problem, another method of collision resolution technique was introduced. That is quadratic probing. Quadratic probing means one quadratic value will be multiplied with the key and then divided by the size of your hash table. So it is an extension multiplication to it. So which will achieve some other hash key for it randomly. So what is the formula we need to keep in mind? H of key is equal to H of key plus X square. X will be some integer within the range of your hash table. You should fix it for all the values which you are inserting into the hash table. Don't change the X value. Once you started inserting the X value into the table, please fix the X value as either 1 or 2. It depends upon your own interest, but still continue with it. Okay? Modulus hash table size. Table size, it depends upon the end user, whatever you want to give into it. So by this also, randomly it generates the value, but it is not the best solution. So another one is double hashing, increasing the size of your table. That means providing the second hash function to it. Once, if you are getting a problem with the first hash function, please give that key to the second hash function and regenerate it. So what is the formula for that? First hash function is key modulus table size. So it must never evaluate to 0. Then only we should go for the double hashing. Another hash function is what? Some random value P, which should be within the range of your some constant, and key mod P. With that P you need to take, where P should be a prime number and it should be within the range of your hash table. Right? These are the some of the scenarios, and the best scenario is your chaining. Best scenario is your chaining. Chaining means once you started inserting any value into the hash table by using the hash function, like h of key is equal to key mod table size, then suppose if you want to insert the values 56, 78, 55, 55, 65. These are the some of the example which you want to insert into it. So your hash table size is only 10. So what is the formula I have introduced for you? H of key is equal to key mod your hash table size. I already told you that we have assumed it as 10. Now, can you please tell me first value? Yes, 56 mod 10. What could be the answer? 6. Then 78 mod 10. What could be the answer? 8. Suppose if you take the first value 56, what is the answer it is returning? 6. So into the table size of the bucket 6, 56 will be occupying. Next, the return value is 8. Into the bucket 8, 78 will be occupying. The next value is 55 mod 10 equal to the remainder is 5. So 5 in the bucket 5, it will be storing the value 55. The next value is 65. See, look at here. 65 mod 10 is equal to the remainder is 5. Here is the situation. We should remember that both the 55 and 65 are obtaining the result as 5, which is leading to the property of collision. So, to overcome this collision property, we need to follow the chaining possibility. That means in each bucket, we will be following a linked list. That means you are going to link 55 with the value 65. So on, it will keep on linked to it. So it continues it. Right? This is what the chaining, one of the method to avoid the collision. Right? Here are the scenarios for avoiding the collision. What is the first method you have learned? Linear probing, quadratic probing, double hashing, chaining. Chaining is the best one where it may take some extra amount of memory to store the values, but still we can avoid it by using it. Okay. Here are some of the examples for it. So first we look at the logic related to the hash table. The hash table contains some basic of size which I have declared already, and initially I took it as an empty array because to tell that it was an empty by using a constructor is empty function, and get bucket is used to retrieve you the index under which we need to follow. Here is the hash function which I want to put into the value, right? And now if I want to remove any key from it, this is the method which will be making the value under it will be null. I'll be assigning the value again to the null. Until if head is not null, that means the list is not created. Then we'll keep on changing like this. Okay. Here is the logic to get the values. That means to display the values in the hash table. If head is not null, then only we'll retrieve the values of it. No. If it is null, the table is empty. I won't return any value. Suppose if you want to add any value, we can add it. If you want to delete or insert, the logics are here. Okay. This is what the performance of your hash table, right? See, look at here. Basically, for any hash table, we need to take the default capacity. That means default table size should be there. Okay. Remember the things of hash table and hash scenario, right? Then the next thing is try to analyze the things of your that collision resolution techniques, ma. Quadratic probing, linear probing, and all. Okay. See, double hashing means double hash functions have been used, right? The thing you need to remember every time is hash keys depends upon the hash table. So it performs some basic steps to analyze it. Every time before going to the coding part, try to learn what operation it is performing and how it is performing. Then after come back to the implementation part of that scenario. Okay. So here are some of the implementations of it. And let me give one more example. One second, I'll share the new document with you, where I'll be performing again the hash table. Right. Think you have taken the, are you able to see the font? Shall I increase it? First, let me take the maximum size, font size. Think my hash table size is some 10. So index, I'm taking it from 0, 1, 2, 2, 3, 4, 5, 6, 7, 8, 9. That means if I take my hash table size as 10, so it starts from 0 to 9. Suppose I just want to insert the value, some random numbers like some random numbers I just want to insert. So the random numbers are 45, 63, 78, 65, 89, 99, 102, 106, like that. Some random numbers I just want to insert into this hash table. By the method, division method, I just want to insert it. So what is that method I just want to follow? Division method. So what is the division method? H of key is equal to key mod table size. What is your table size? You have taken 10. So that we need to take. Okay. So this is what the formula for the division method. Now suppose if I write the thing like 45. First key I just want to insert is 45. 45 mod 10. What is the remainder? Equal to 5. So into my fifth location, I'll be adding the value 45. Now, this is what the next value is 63. So what is that 63 mod 10? What is that 63 mod 10, ma? 63 mod 10 equal to 3 remainder. So under the third location, yes, ma. Please, I'm sorry with small mistake. I couldn't share the new one. Please look at here. Here I have taken the hash table with the size of 10 from 0 to 9. Now I just want to insert this particular values into the hash table by using the division method. Then please look at the value that 45 mod 10 equal to 5, 63 mod 10 equal to 3. Then next 78 mod 10 equal to 8. So under the 8th location, 78 will be stored. 78 will be stored under the 8th location. Now, next, 65 was there. So what is the return value of it? 65 mod 10. The return value is 5. Please look at the scenario that already fifth bucket is filled with the 45 value. But still 65 is also getting the same value. The return value is 5. So This particular situation is called as the collision. So we need to resolve the collision. So how to resolve this collision? The chaining. So we'll provide a link between the next node by using the linked list. That means in each bucket, we need to have a linked list. So here you need to perform the dynamic memory allocation method by using the malloc. You need to create the node, and in the each node, we'll be having the value 45 followed with the next node address. Suppose in the bucket, if it is having only one value, the next node value will be none. But here is the scenario, it is having more than one. No? So it maintains a link between the 45 and the next value, that is 65. So like that, it continues the process by using the chaining. Now please look at this 89. 89 mod 10 means reminder is 9. So under the 9th location, you are going to insert this 89. The next value is 99. Please check this thing. Here also it is retrieving the reminder as 9. So it is giving a, what I mean to say is, it is getting back again into the collision technique. So please try to maintain a linked list over here, and please attach the address of 99 to the 89. So it will be linked into the particular location of the 9. How we are going to do means by using the malloc method, which will be done by the program. I'll just show you now. Meanwhile, try to look into that. If you get a collision, please, we are going to put that in the same bucket, but still we are using it by the scenario of dynamic allocation. Now, please look at this 106, which will return you the reminder of 6. The bucket is empty. We can happily insert over here. So 106 will be added into the bucket. The next value is 102. The reminder is 2. Bucket is empty. We can add it. So these are the some of the values. By this, we can add up into the hash table. Right? So how to resolve this collision technique? By using the chaining. How the chaining will be done? By using the linked list. How the linked list will be created? By the dynamic allocation malloc function. Malloc function will contain 2 arguments. First argument is the number of, size of your data type. What is the size you want to take? Either int, char, float or double. Then the next argument is how many number of values you just want to put it. Whether 1, 2, 3, depends upon your criteria. Okay. So here is another one. Are you comfortable with this collision resolution technique? Okay. Can I go with the next one?
Yes.
Okay. Once you finish with the collision resolution technique, please try to analyze the B tree and B+3 scenarios also. Then the next topic is priority queue. Before going to the priority queues, I just want to revise the queues concept once again. Queue is a linear data structure where it follows the property or principle of first in, first out. That means what is the first element inserted into the data structure, that should be retrieved output, right? And it can be inserted with any type of data type. That is int, char, float, double, depends upon your criteria, what you want to take into your code, right? So priority queues means based upon the priority which is given by the end user, the values will be inserted into the queue, right? Which is associated with a key. That means priority is depending upon a key value, right? So the key definition will be done by the end user only. That means the end user has to give the priorities, what you want to give to that value and the value, right? Always remember the minimum priority will be given the least priority. That means least it will be inserted. Maximum priority value will be inserted first. Right? Like this, the priority values will be changed. Inserting and deleting. And the heap comes. I'm going to share the screen for you. Then suppose the thing we need to remember over here is max heap and min heap. Max heap means the root node is always maximum when compared with the left and right children's. And if it follows the min heap, no, the root node will be minimum when compared with the left and right children. So this is what the heap property which we need to look into the careful, right? Here is the priority queues program. Before going to the implementation of this priority queue, please remember the property that if the key is having maximum priority, then it will be inserted into the tree frequently. If it is having minimum priority, it will be deleted from the queue. So please look at the implementation part of it carefully. So here we go with the constructor. First, we are taking the table size with the maximum capacity which you want to take it. So initially the heap size is 0 because it is not inserted with any of the values. Clear is the method to clear all the values, to empty the hash table, right? Heap, if it is full, it will return the size of it, right? Then size means how many number of elements are there. Insert is the main function what you need to keep concentrate upon it. You need to allocate the memory. Please increase the size. Please enter the position and check the heap property. If it is greater, then you are inserting into the left child. If it is less, you are inserting as a right child. Like that, it remains. So remove method means deleting. If the heap is empty, that is nothing in the tree. So it will be deleted, right? So the properties continue like this to remove it. And this is what the task to enter the thing. And this is what the main method where we are invoking all the methods from here. By using the cases, menu driven, I have written this code in order to insert an element or delete an element. Okay? Right. These are the different scenarios. Suppose if I want to continue the repetition of the insertion or deletion, here I have kept a do while loop until I press any other alphabet rather than the Y. I'll keep on inserting the values. I'll be scanning it by using the caret method. Right. So please look at the sample output. I've saved it priority queue test.java, but we are using the Java software. So please give an extension .java to your file before you start saving it. Right. Once you get compiled without any errors, please execute it by a command called Java space file name. Right. So the first menu it will be getting as priority queue test. Then please enter the size of your priority queue. Think I have given 5. What are the operations I am performing? Insert, delete. Delete means remove. Check is empty, is full, clear, size. Right. Enter the name. What is the job name and the priority? Job 1 I have given and the priority I have given it as 4. So highest priority it will be performed first. So do you want to continue? Yes, I pressed 1. So it will ask me whether you want to insert it or you want to delete it. Yes, I gave it as a job 2. Insert I press and I gave job 2 its value. Then I am pressed again. I am taking one more thing and I am continuing the process. One more job with the priority 1. So job 1 is having the priority 4. So how it will be removed means last. Least priority will be removed first. Okay. This process will be continued. This is what the sample output to it. So here is the code for your binary heap. This is an assignment to you. Please write a code to implement the heap properties. Max heap and min heap. Heapify the tree every time. Okay? Yes? Okay. Sorry, ma. Due to some network issue, my network is getting blinking. Can I stop this class for today? I've concluded the specialized trees and hashing. Please revise these 2 topics. I'll continue in the next class. Okay?
Okay.
Please leave the class for right now.
Thank you.
Thank you, ma. Thank you so much for understanding.